Okay, so here is a question where we're given some kind of force over here, and we're trying to find the x and the y components. And likely, if you're given a graph, the force you're given is probably some kind of diagonal force. You're just finding the x and the y component. So first, if we want to solve this, one way you can see it is like a right-hand triangle, where this force is the hypotenuse. So if we draw it something like this, and we have our force here, so let's say that's 50 newtons, but we also have the angle, which is 30 degrees. So if you know trig, you might be able to solve for this, which is the adjacent side, and the opposite side. And the adjacent side will be the same as the x component, and the opposite side will be the same as the y component. So how can we solve it? So if we want to go back to previous math classes, SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So if we want to find this side, which is the adjacent side, using this hypotenuse, well, which one involves both adjacent and hypotenuse? Well, it's cosine. And so if we can rearrange it, if we multiply the hypotenuse to both sides, we get h cosine theta equals adjacent. So we already know what the hypotenuse is, and we already know the angle. And so hypotenuse is 50, cosine, and the angle is 30. And we should get A. And so our answer is 43.30. Let's put it in 4 sig figs, or if it's our final answer, I guess we can do it in 3 sig figs if you're an engineer. And so yeah, that would be in newtons. Okay, so next is the y component. So we already know this one, it's 43.3. So if we know this and we're trying to solve for the opposite, we could use tangent, but let's just stick with using the hypotenuse. So opposite and hypotenuse, which one's involved in SOHCAHTOA? Well, it's sine. And so if we multiply the hypotenuse to both sides, we get hypotenuse sine theta equals the opposite side. So we know what hypotenuse is, 50, sine, and the angle is 30. And that should give us the opposite side, which equals 25. And let's put it 3 sig figs as well. Now, just a reminder, put your calculators in degrees mode if you're given this angle. And so this is basically our answer. The force in the x direction is 43.3 newtons, and in the y direction, it's 25 newtons. Now, you might be asked to put it in Cartesian form, and so if we do it in that form, you'd put it like this. The x component is 43.3, and then the x direction would be I hat, and then plus 25.0 j hat, and then newtons. Now, these are both positive because if we just look at the context, the x component would be turning to the right, and the y component seems to be going in the positive direction. But of course, if we had some kind of force going this way, whatever, and let's say this was also 30, if we calculated the x component, it would be also positive, but we also, in this context, the y component would be going down, and so we would have to write this as negative. And so that's how you solve it. Let's do a problem where you solve this for yourself, where you find the x component and the y component. So you can pause the video right here, and once we're done, we'll go over it. So in this case, we can treat this as a triangle going this way. And so this angle would be 25 degrees, and this is the hypotenuse, so this will be 75. So how can we find this component? Okay, so if we're trying to find this is the adjacent side. So which one involves the adjacent and the given hypotenuse? Well, it's cosine, and so if we multiply hypotenuse to both sides, we get this equation. So we know the hypotenuse, 75, cosine 25 degrees equals the adjacent side, which equals, let's do this in a calculator, 67.97, or in 3 sig figs, it'll be 68.0 newtons. All right, so that's what this x component is. Now let's try find the y component, which in this case would be this side, which is the opposite side of the triangle. So if we know the opposite side and we know the hypotenuse, we can use sine, and if we rearrange the hypotenuse sine theta, which is 75 sine 25. That should give us the opposite, which equals 31.7 newtons. But if we look at the context, this would be going down. So this should actually be negative. All right. So in the x direction, it would be 68.0 newtons, and in the y direction, it would be negative 31.7 newtons. And in Cartesian form, if we write it as a vector, that is, it would be 68.0 newtons. Oh, no. I had minus 31.7 j hat and newtons. So there you go. If you enjoyed the video or if this helped, please like and subscribe. And thanks for watching.